Parallel lines. Lines are parallel if and only if they have the same slope. If you think about a graph, if this line has a slope of, I don't know, what does that look like? 3, 2, whatever that looks like. In order for another line to be parallel, parallel means they are never going to touch and never going to cross. Both lines have to have the same rise over run so that they will constantly be increasing by the same amount so that one of them won't gain on the other and end up making them cross. So parallel lines must have the same slope. So if line 1 has a slope of 4, what would line 2 have to have a slope of? 4. Perpendicular lines. When we think about a graph, if this is our first line, what kind of slope does that purple line appear to have? Positive, negative, 0, undefined. Positive slope. A perpendicular line, a line that meets that line at a 90-degree angle. So if this is line 1 and this is line 2, what type of slope would line 2 have to have? Negative slope. So for perpendicular lines, one of them has to be positive, one of them has to be negative. So here's this first word in the definition. Perpendicular lines, their slopes must be opposite reciprocals of each other. So I'm going to make a little table for line 1 versus line 2. And we're going to look at some possibilities here. Hopefully after a few examples, you guys will get it. If line 1 has a slope of 3/4, in order for line 2 to be perpendicular, what would the slope of line 2 have to be? Negative 4/3. So notice line 1, positive 3/4. Line 2, negative, opposite. Reciprocal, flip that 3/4 over to make it 4/3. So let's say line 1 had a slope of negative 3/2. What would the perpendicular slope be? I like the 2/3. Would it be positive or negative? Positive. Let's say line 1 has a slope of negative 1/2. Just flip it. 2 over 1, which is simply 2. And line 1 is negative, so line 2 is positive. All right, let's do a little bit more difficult. Let's say that line 1 has a slope of 4. Negative 1 over 4. Remember, 4 is 4 over 1. Flip that over. 1/4, make it negative. Does that seem pretty easy? The other trick is if you multiply the two slopes together, they will equal negative 1. If you take negative 3/2 times 2/3, negative 3 times 2 is negative 6. 2 times 3 is 6. Negative 6 divided by 6 would be negative 1. So perpendicular slopes have a product of negative 1. All right, so in numbers 1, 2, and 3, we need to find the slopes and then decide, are these lines parallel, perpendicular, or neither? So take a moment and find the slopes of line 1 and 2 in number 1. Okay, line 1, you should get a slope of negative 3. Line 2, you should get a slope of positive 1/3. So how would you describe line 1 and line 2? Parallel, perpendicular, or neither? Perpendicular. And if you really don't want to write out the whole word perpendicular, do you remember the geometry symbol that means perpendicular? The upside down capital T. So if you write an upside down capital T and box it in, make it obvious, I will accept that as an answer. If I have to hunt through your work to find it, that's not cool. But if you make it very obvious and put a box around it, that will work. Do you remember the symbol for parallel? Parallel is 2 slashes. Perpendicular is an upside down T. All right, line 2. Let's find the slope of line 2. Okay, line 1, did you get 0 over 9? What does 0 over 9 equal? 0. So the slope of line 1 is 0. Line 2, I got 2 over 0. What is 2 over 0? Undefined. Do not write 2, do not write 0, write undefined. In fact, if you want to put a slash through the 2 divided by 0 to show that, hey, you can't even do this, that would be good. It kind of bothers me actually to put an equal sign next to 2 divided by 0 because you can't. It doesn't equal anything. It's not possible. So, are these parallel, perpendicular, or neither? They can't be parallel because they aren't the same. We need to think about what do these slopes mean. So line 1 has a slope of 0. A slope of 0 means it's a horizontal line. An undefined slope, what type of line is that? A vertical line. Now that you see them, are they parallel, perpendicular, or neither? They are perpendicular. A horizontal and a vertical line will create a perpendicular situation. So these are perpendicular. So if the slopes are the same, parallel. If the slopes are opposite reciprocals or 0 and undefined, they're perpendicular. And if it doesn't match any of those scenarios, then it would be neither. Neither is an option. So don't forget that neither is an option. Take a moment, find the slopes for line 1 and 2 in number 3, and then we'll talk about that answer. I have had students tell me that these two are perpendicular because the negative is in a different place. Is that correct? No, that is not correct. If you were to plug this into a calculator, -5 divided by 4 is -1.25. 5 divided by -4 is -1.25. Where the negative is doesn't matter. You should actually take this second slope and rewrite it as -5 over 4 because it's most correct to put the negative on the top. But no matter how you look at this, these slopes are the same, so these two lines are parallel. The slope of a road, or the grade, is usually expressed as a percent. Have you driven in hilly, mountainous areas and seen like the hill ahead sign and then there's a percentage listed underneath it? That is the grade of the road. So if a road has a grade of 3%, it rises 3 feet for every 100 feet of horizontal distance. And when I was bored on our drive to Colorado, I actually looked up what the requirements for interstates are. I don't remember what it is, of course, but there is a requirement that in order for a road to be an interstate, it has to have less than a certain percent grade for all hills, both up and down. There are a few exceptions on some interstates. If any of you have driven west of Denver on I-70, there's some places where it's pretty steep up or down. Those are a few exceptions in the interstate system. I found that to be interesting. I don't know if you guys find that to be interesting, but I find that to be interesting. So we have a road that rises 75 feet over a horizontal distance of 2,000 feet. So instead of saying rise over run, they're talking about rise, so the vertical rise versus the horizontal distance, that would be our run. So they want you to find the grade of this road. So 75 is the rise over 2,000 is the horizontal distance, the horizontal run. So grab a calculator, beep, bop, boop. What is 75 divided by 2,000? Okay. We are going to talk about how to change this into a percent, because I guarantee there's at least one person who does not know how to change 0.0375 into a percent. And that's okay. There's always time to learn. Take the percent, or take the decimal point, and move it 2 places to the right. This would be 3.75%. Or you can take this decimal and multiply it by 100, and that will tell you what percent it is. In example B, they're asking you to analyze and use this information. So find the horizontal length x of a road with a grade of 4% if the road rises 50 feet over its length. We have unknown information here. We do know that the grade is 4%, and that means 4 feet vertical rise over 100 feet horizontal length. This needs to be equal to our road. On the top, we know that our road rises 50 feet over its length, but we don't know its horizontal length, so we put x in that spot. Do you remember how to solve a proportion, fraction equals fraction? Cross multiply. So they're asking you to take known information. The grade is 4%, write that as the fraction. Create a proportion with what you know and what you don't know. Cross multiply and solve. So 4x equals 5,000. Divide both sides by 4. What is the horizontal length of this road? (1,250 feet). Don't forget to write feet. The number of U.S. cell phone subscribers increased from 16 million in 1993 to 44 million in 1996. Find the average rate of change, then use it to estimate the number of subscribers in 1997. Before we start, I have a question for you. Does subscribers per year make more sense, or does years per subscriber make more sense? Subscribers per year. So if you take a moment and think about that, that's going to help us set up our rate of change. Have you used the little triangle delta to indicate change? So we want the change, delta, the change in the number of subscribers over the change in the number of years. That will tell us the rate of change. So change in subscribers from 16 million to 44 million. You do 44 minus 16. What is 44 minus 16? 28. Over the change in the years, 1993 to 1996, you can do 1996 minus 1993, or just think about it. 1993 to 1996 is 3 years. 28 divided by 3. Let's get an actual decimal, something that we can kind of analyze a little bit. 9.3 repeated. So the rate of change is 9.33 million subscribers per year. So first question, find the average rate of change. Done. The rate of change is that it's increasing by 9.33 million subscribers per year. Second, estimate the number of subscribers in 1997. Well, in 1996, we had 44 million subscribers. We are increasing by 9.33 million